All right, let's get into it. You know, a high-level computer science exam, it's not just a test. Think of it more like a puzzle. A really complex, but totally fascinating, and, most importantly, solvable puzzle. In this explainer, we're going to crack it wide open. We'll break down its structure, find the hidden patterns, and lay out the exact strategies you need to conquer it. I like to think of it like a video game, right? You spent all this time leveling up, learning the skills, and now you're face-to-face with the final boss. Of course, it's going to look intimidating. It's designed to test everything you've got. But just like any boss in any game, it has weaknesses, it has patterns, and there's always a strategy to win.
And trust me, that feeling is completely normal. Even the experts who train students for this exam have a name for it. They call it the big coding question, which of course puts fear in all of us. That fear is real, but it's also a big, flashing sign pointing us to the main challenge we need to take apart piece by piece. So, let's get started.
So first things first, to crack any code, you have to understand its basic structure. In our video game world, this is the map of the level. You've got to know the layout of the battlefield before you can even think about planning your attack.
The entire course is really built on 3 core pillars: software design, web design, and database design. And here's the key thing you need to know. Students have to learn the fundamentals of all 3. You can't just pick and choose your favorites here. But here's where the strategy starts to come in. Even though you have to learn everything, when you actually sit down for the exam, you get to choose a path. You either answer the questions in the database section or the web section. You don't have to do both, and that is your first big strategic decision. But there's a hidden rule, a little trap that catches so many people. It's called integration. See, just because you chose the database path doesn't mean you can forget everything about the web, and the other way around. The examiner reports mention this year after year as a place where students lose easy marks.
Okay, so knowing the structure is step 1. Now we can start looking for the cheat codes. Because even though this exam seems impossibly complex, it's a system. And like any system, it has patterns. Experts spend years just analyzing old exams to find the predictable bits inside all that chaos.
And this quote right here proves it. The whole point of the exam isn't to surprise you. It's to test a set of core concepts. And that predictability? Well, that's your single biggest advantage. It means you can pretty much count on seeing certain types of questions again and again and again.
And this isn't just a theory. We've got the data to prove it. Look at this. For the last 3 years, you could have absolutely banked on getting questions on object-oriented programming, linked lists, 2D arrays, UML diagrams, and testing. Knowing this changes everything. It turns that panicked, I have to study everything feeling into a focused, strategic plan.
Now we get to the really good stuff. After every single exam, the people who write it release a public report. It details exactly what students did right and, more importantly, what they did wrong. You should think of these like secret intelligence briefings from the other side. They're telling you the most common mistakes and how to avoid them. And here are some of the biggest takeaways. Examiners are constantly warning students to explicitly state their data types. They see people using basic maintenance terms when they're looking for the advanced ones: adaptive for adding new features, corrective for squashing bugs, and perfective for making it run better. And a huge one, don't just spit out a definition, you have to apply it to the problem they give you. Oh, and my personal favorite, for object-oriented questions, the answer is usually hiding in plain sight in the diagram they give you in the question.
They also mentioned polymorphism, which I know sounds like a super intimidating word, but really all it means is that one piece of code can work with different types of objects. It's the ability for something to take on many forms. It's a huge concept for writing flexible code. And yeah, the examiners definitely expect you to know it.
Okay, let's circle back to that all-important integration idea. The examiner reports are crystal clear about what this actually means in practice. If you choose the database path, you absolutely must know how to build a basic HTML form. And if you choose the web path, you absolutely must know how to write a simple SQL query to get data from one table. It's that specific. And that brings us here, to the final boss, the big question. This is that huge, multi-part coding problem designed to test everything you've got under pressure. This is where most students lose their nerve, but it's also where you can make up the most ground if you have the right strategy. So here's the game plan. Step 1. Leave it for last. Seriously, go get all the other marks you can, build up your confidence. Step 2. When you get to the question, your first job is just to figure out the main data structure. Step 3. Pinpoint the algorithm. Is it a standard one, like a search or a sort, or do you have to create something new? And step 4, and this is maybe the most important, attempt every single part. The question is designed so that almost anyone can get some points. Don't leave it blank.
But where are the points really coming from? You'd probably guess it's all about nailing some super complex algorithm, right? Well, the data shows that's just not true. The huge majority of marks, the high-value stuff, comes from basic data manipulation. Just moving through an array, changing some values, shifting things around. These are the fundamental skills you've been practicing for years.
And if you want a real insider tip, the reports point us to a very specific weakness. Year after year, one standard algorithm trips students up more than any other, the insertion sort. Just knowing that gives you a massive advantage. If you can really get your head around that one tricky algorithm, you are already way ahead of the game.
And really, this all leads to the single most important piece of advice you can get. This quote just says it all. The goal isn't to be perfect. The goal is to make progress. Just showing that you tried, that you have a thought process is a win. Don't let the fear of not getting full marks stop you from getting the marks you totally can. Because at the end of the day, learning how to pass an exam like this isn't just about computer science. It's a masterclass in how to look at a huge, intimidating challenge, break it down into smaller, solvable pieces, and then just tackle them one by one. And that's honestly one of the most valuable skills anyone can ever learn. So the only question left is, what complex problem are you going to solve next?